We'll kick off the last talk, so round of applause for Abdul, everybody.
Hi everyone, can you all hear me fine without the mic? Yep, great. Okay, so that's me. I've been involved with technology for quite a while. Really long time ago when I was writing software on microcontrollers that didn't even have interrupt lines, and it was all in assembler and a bit of a nightmare. But right now, the thing that's interesting me the most is why is it that we have so many organizations where building software is a problem? And the thing that's interesting me is how to build an organization that builds a software product. So what is it that we need to do? We've gone through a ton of stuff around Agile and Scrum and Kanban, and still have backlogs that are growing. So that's my day job. But my first love is still technology, and I spend quite a bit of time doing software development. So self-initialized fakes, that's a thing I came across on Martin Fowler's site, and it looked fairly interesting in the context of writing tests. And this is no longer controversial. The idea that we should be writing tests as we write software, it's pretty much settled. There's probably discussion around what kinds of tests we should be writing, and there's the testing pyramid and lots of arguments about where test belongs and whether this is a unit test or an end-to-end test or a acceptance test and who should look after it and all of this. But we know for sure we should be writing tests. This is the way in which we're going to get to software that's scalable and maintainable. So one of the things we have going at the moment, microservices, or at least external systems. So you're often writing tests that talk to external systems. So what are you going to do? Ideally, you want your tests to be really fast. The idea here is that quick tests, while you're developing, you will run those tests. If the tests take a long time, you're going to spend 5 minutes waiting for the test to run, maybe even 30 seconds. You're going to get distracted by Twitter or Instagram or coffee or something of that sort. But basically, slow tests are not amenable to flow. If you're going to be running your tests on a regular basis, you need these tests to be fast. So this is a problem. You've got external services. You want tests to run fast. We all know that external tests take a long time. Just connect to a service, there's TCP handshake, then there's HTTP on top of that if you're running HTTP, and basically time is going. So mocks, that's the first thing we think about doing. Let's mock our services. And then we discover that this thing we keep testing against is not really the thing that we're interested in having results for. It's like the tests look good, but they don't translate. It's like somebody changed the API. I didn't know about that. I created a mock. And this is the thing about mocks. They're really not my favorites at all. Mocks basically will do anything. And in a testing environment, sometimes it looks like your test is passing. Your test is passing. But no, they're not. So what about test doubles? So you can write fakes. A bit more work than a mock. But then you end up with a ton of code that you've got to maintain just to get your test to work. And it's just as easy for that code to get out of sync with the external system that you're trying to test against. So now not only do you have a system that can break really easily, but you're maintaining twice or 3 times as much code as you really need to maintain and reason about. So not great either. So what you really need is something that's going to fake it well enough without you doing too much of work. And this is where software engineering really comes into play. So I'm a great fan of upfront design. I know a lot of places don't do that much anymore, but anyway, software engineering principles, solid principles, dependency injection, all of the things that I like. So interfaces. Go's got interfaces, not the first language with interfaces. but they're really, really useful for this kind of thing. So what does it all look like? I'll show you that in a moment. I just want to talk about a couple of things that we've got to be careful with these self-initialized fakes. They work best in a command response system. Typically, that's what we're doing. We're sending a request to an external server, we're expecting a response back. And those things tend to be the same all the time. You've got to be careful about state. If you add a user in the external system and you add the user again later in your test, that system, you're going to get back an error. So the first time you'll get back a 201 object created, the second time you're going to get 400 error going, fix your problem and come and talk to me again. So you've got to reason about these things. What does the external system look like? Ideally, you don't have to worry about it too much, and I'll show that to you in a moment. So interfaces. Let's assume I'm talking to the external system, and that's the interface I've created. So all of my code talks to this interface. I don't care what's happening beyond that. So this is the idea with interfaces and dependency injection. You are encapsulating some unknown behavior, some system that you don't control behind an interface that you do. So everything that you don't control is behind this interface. All of your code on this side of the interface you control, you can deal with that. And what does this allow me to do? Well, I can create a transport object that adheres to this interface. So it's got open, close, read, and write. And if it's a TCP transport, I initialize it in some way. And more importantly, if it's a fake transport, I initialize it another way. But as far as the interface is concerned, both of these transports operate in exactly the same way. They've got an open, a close, a read, and a write. So one interesting thing about the fake transport here, two interesting things. One, it itself takes a transport. So I'm kind of lazy here, so the transport that I've already written to talk TCP IP, I want to reuse that, so I can just drop it into this one. And it has a cache. So that's the bit that gets us a whole lot of useful bits. And just as an example, I wrote a small function for all of my tests can use that creates one of these fake transports. And that's the test we're going to look at. It's fairly straightforward. You'll see that from the point of view of this test, it doesn't know whether it's using a fake transport. It does know the first line gets a transport. But the rest of the test, all of those methods that are part of my application, they don't know whether this is a fake transport or a real transport. All they care about is that they're getting an object that adheres to a particular interface. That's it. So where do we go to from here? I've got effectively a test. I'll show you what the test looks like, but I've got a test here that in fake mode runs and, let me just, get it to, so real demo. I hope this thing works. But the idea here is that this test ran against an external service, connected to that service, and took 11 seconds to run. And I'm going to tell this test that actually I want you to run in fake mode, and now that test ran in 2 milliseconds. That's a huge saving. It's a slow network. So how does that all work? So basically, this is what my fake looks like. And you'll see that you would have remembered that when I created the fake, I passed in a transport. And if you look at an example, the open and the close methods, so all the fake does is if you're running in fake mode, it does nothing. It returns on an open, and it returns on a close. So there's no TCP IP connection, nothing of that going on at all. And if I'm running in fake mode and I'm doing a read, so if you look at that, If you're in fake mode, do a fake read, otherwise do a real read, returning, and if you look at the real read, that's calling out to the real transport, the TCP transport, and returning the results. But if you look at the fake read, it's going to cache. And this is exactly the opposite that happens in the write. So if you look at the writes, if I'm in fake mode, I'll do a fake write. If I'm in real mode, I'll do a real write. But if you look at the real write, it keeps a key, and so the fake write doesn't do much, but the real, the fake read reads from the cache instead of reading from the real system. So all we're doing here is wrapping a cache around the stuff. So you get a command that goes out to the real system, create a hash of that command, get back a response, save that response against a hash. If you're in fake mode, then you just replay that hash. That's it. There's nothing else to it. And in terms of saving time, it goes from 11 seconds to 2 milliseconds, and I reckon that's a win. And that's it. That allows you to write a lot of the, and that's it. Once you've done that, as simple as that, the rest of your commands, it doesn't matter how many you've got, so long as they're unique, which they generally are, and you can hash them. You can replay them. I just want to show you one other thing, and that is, this happens to be a TCP/IP system using XML, so if you haven't seen XML in a while, that's what it looks like. Not much fun, but this is an example of a response that came back from the system and gets written to file. One of the things I do with this project is all of the responses are written to disk, and I commit those hashes as part of the project as well. So if I pull up new projects, come back to work on the project, run the test in fake mode, everything works immediately. Sorry, I'll answer your question. One other thing to remember here, if you run in not fake mode and the remote system has changed in some material way, the tests actually end up failing. And at that moment, you've already got the new response in cache. All you need to do is figure out why has this test failed, make the changes, and do that. So that's the most powerful part of this thing. And I almost forgot to mention it, is the fact that you can recreate these responses at any time. You just go out of fake mode, run all of your tests, and you'll get a fresh lot of responses from the system. And that's an ideal time to go and grab a coffee or something of that sort. But when you come back, if all your tests have passed, the remote system hasn't changed. If any of your tests have failed, you know exactly what's caused the problem, because you can tell from the responses that are on file what's changed, make your changes, and you're good to go.
So that was one of my questions.
Yeah.
A good answer to that. My question was, how do you deal with services where the responses change?
Yeah.
But the second part is actually a slightly harder case of the same question, where your command response actually includes a challenge response type question,
Yeah.
or it's time synchronized, or it's something like that.
Yes.
Are you sort of faking that out in another way?
Yeah, so a lot of this does depend on your use case. So in this use case, for instance, there's a polling command that most times will return nothing, and on some occasions will return something. Yeah, so you're going to have to figure out how to deal with those circumstances depending on what it is you have. So here, that transaction ID is something that changes on every request. So in my test, I don't care about the transaction ID. I care that, do I get an access granted if I give it a valid username and password, and do I get an access failed if I don't? So that's the bit I'm interested in, whereas transaction ID would be something I'd be interested in when I'm working on the audit stuff. Yes, so those are the kinds of things that you need to think about. The proviso is you want your interface to be exactly the same. So how you send through this additional information to say that this request is different from a real request, you start getting into areas where, well, I guess your abstraction is starting to leak, right? So that's really where yeah.
The idea of having like your fixtures, or that's not the right word, but like a file representation of what the response should there. Have you tried other approaches to essentially the same idea where you're testing with like, you know, your file base, like this is what it's supposed to look like, and versus the live right. Like, so your fake and real things and your different transport stuff, like the way you are like packaging, testing the real thing versus the fake thing. Have you tried other options other than this, and were they better or worse, and what sort of problems led you to this specific approach of testing real and like
yes.
fakes in this way?
So I touched a bit on this earlier on, and it really had to do with if you're creating doubles or using mocks, you end up building into your test your knowledge about what the external system is like. And every time the external system changes, you tend to find that out only at integration points. And then even when you do, you end up having to go back and change code that you've written. So your test code starts changing because the external systems change. And I don't know if anybody's told you this, but programmers are really lazy people. And the first thing I was interested in is, how do I not have to do that kind of stuff? So I don't want to deal with those kinds of, when things change, can magic happen so that I don't have to change a lot of fixture code? So obviously my test might need to change to, if the layout has changed, or the access, instead of returning 1,000, they're returning 1,001 for whatever reason, that kind of stuff. They've changed the layout of the response. I'd need to change my interface. But I don't want to have to write code to say that this is how that object now behaves. My test code starts returning 1,001. I don't want to have to do that, or the mock.
What's been your experience of dealing with a sort of loss of control? So if you're integrating against a system that you can manipulate, you have to somehow be able to set the remote system up in a state that will give you a response that you want. How does that work out?
Yeah. So typically, this is a kind of thing that you'd probably want to test against a staging system, so not production data. But on the assumption that I don't have control on that system, I try to do things like create records and then ensure that I delete those records so that at some point my state is known. But yes, that's an important part of this thing. You've got to be aware of what the state on that system under test is.
Are the fixtures changing? Like, do you record them in the original format?
Yes, yes.
You could just change the fixtures?
Yeah. This here is written directly from the remote system and goes straight out to disk. So, and that was the other thing. I wanted it to go out to disk because I wanted to be able to keep this over multiple runs, years or whatever it is, to be able to rerun these tests without necessarily needing the remote system. But it could be anything. I mean, if you really don't care about that, you could use an in-memory cache as well.